This is question 7 from the January 2023 CSEC Mathematics, paper 2. It says the grid below shows the first 3 figures in a sequence. Each figure is made using a set of small squares of unit length that are both colored or shaded, and white, which is unshaded. Alright. They say in the space provided below, draw figure 4 of the sequence. I'm going to just copy this part of the question and put it over here. So here we go. Let me kind of make it a bit larger. Alright, so you see what happens here now. We're supposed to shade the new shade the new figure 4. You can see here that you have 3 going across and 2 going across and 1, 2, 3, 4, 5 going across. So there should be 6 going across here. So let's see if we can shade that. So you have 1, 2, 3, 4. Alright. What I'm going to do, you see, let me zoom in a bit and then shade this. I'm going to shade it now. Let me just shade it in this color. Right. So you should have 6 going across. Let me just copy this. Good. We have 1, 2, 3, 4, 5, 6. No. Oh. So you should have 6 going across. 1, 2, 3, 4, 5, 6. Oh. Then to the left, the one that's on the right, you don't have any shaded under it, but one place to the left of it you have. So if you have 1, 2, 3, 4, 5, 6 going across, this shade should be under here. And then you have diagonally other shapes going down. Alright? Now let us try that and see what happens. Just move downwards, but how many? You move until you get a shape directly under the one on the left, based on what I'm seeing here. Alright? So, like we need 2 more of this. So you have 1 here and the other here. Good. So we have the shading done. Let's see what else it said. The number of colored squares, C. The total number of squares, T. And the perimeter of the figure, P, follows a pattern. Follow a pattern. Study the pattern in the table below and answer the questions that follow. Complete rows 1, 2, and 3 in the table below. Alright. So we should complete rows 1, 2, and 3 Let's copy the table. And put it over here. Let's pull it down. And put it below here. I'm going to make it a bit larger. Alright, good. Now, let us see what happens here in this case. Figure 1, you have 5 colored squares. In figure 1, 1, 2, 3, 4, 5. Okay, good. The perimeter of figure 1 is 12. Alright, that's what I mean here. The perimeter of figure 1, going around figure 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, you have a perimeter of 12. Good. Then you have total number of squares. 1 plus 2 squares is 9. How many squares you have? 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Remember, it says some shaded, some unshaded. So you count all the squares. So it's really one side of it and you square it to get the total number of squares. Here now, number of colored squares in figure 2 is 7. So the colored squares in figure 2, you have 1, 2, 3, 4, 5, 6, 7. Okay. And they say the perimeter is 16. So you have 4 going across. So it's 4 plus 4, 8, plus 4, 12, plus 4, 16. Okay, good. And then total number of squares, 16. 2 plus 2 square, which is 16. Alright. 4 by 4. You have a total of 16 squares. Let's see figure 3. Total number of colored squares is 9 in figure 3. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 colored squares. Then perimeter of the figure is 20. Okay, so you have 20. So in that case, what you have is 5 and 5, 10 and 5, 15 and 5, 20. Alright, so perimeter is 20. So you see that total number of squares is 25. You have 5 going across, 5 going down. Yes, it's 25, including both the unshaded and the shaded squares. Alright. What they're saying here is, if you had a figure 11, you must find the number of colored squares. You have the perimeter there and the total number of squares. Interesting. Let us study this pattern first. 1 to 5, 2 to 7, 3 to 9. So if there was a 4, alright, I notice 1, 2, 3, then you have 4, 5, 6, and so on. But the number of colored squares, if you had matching colored squares for the 4, 5, and 6, you have 5 for 1, add 2 to 5, you have 7 for 2, add 2 to 7, you have 9 for 3, so you add 2 to 9, you would have 11 for 4. For 5, you add 2 more, so you get 13. For 6, figure number 6, you'd have 2 added more to get 15, and so on. Alright, so it would be 4, 11, 5, 13, 6, 15. But Let us see how could we generate these numbers otherwise. Let's see something here. If you have 1 and then you have 5, you would say 1 plus 4 equals 5. Alright, what about the 2 and 7? 2, something happened and you have equals 7. Remember, we're looking at these figures here, over here. You have 2, the figure number is 2, and the number of squares is 7. If you say 2 plus 4, you get 6, not 7. But suppose you say 2 plus 4 plus 1, you get 7. 2 and 4, 6 and 1, 7. Alright. If you say 3, something happened to 3, and you get, what is it, 9. Oh, you get out 9. You'd have to say 3 and 4. 3 plus 4 is 7, but it's 2 more. You say plus 1 plus 1. You could say plus 2, but let me see. Suppose you say plus 1 times 2. Plus 1 by 2. Alright. Now, if you have the 4, something happens to the 4, and you get out 11. This is something happened with 4, and over here you get equal 11. What could it be? Plus 4. It seems as if the 4 is a common factor throughout. So you have something plus 4, plus 4, plus 4, plus 4. Let's see. Now, 4 and 4 is 8, but you'd have to add 3. Oh, suppose you say plus 1 by 3. Alright. So, here now. Let's continue and see how it will work out. Let me move these further down. By the way, we're going to get something happen to these numbers. Are you going to have equal 15? And then with the 5, since the 4 seems to be common throughout, you say 4 and then plus. Follow this pattern. This is 1 by 1, 1 by 2, 1 by 3, 1 by 4. But 1 times anything is that thing itself. So let's eliminate the 1 times. The 1 times, let's eliminate that. So what you have is 1 plus 4 equals 5. 1 plus 4 by 1 plus 1 equals 7. 3 plus 4 plus 2 equals 9. 4 plus 4 plus 3 equals 11. 5 plus 4 plus 4. 4 and 4 is 8. 8 and 5, 13. If you go to this 6 now, remove the 6 1 up here, right? Let's move this here and this here. Now, if you say 6 plus 4, then you say plus 5. 6 and 4, 10. Okay, and 5, 15. It seems as if this is working out, but guess what now? we need a common, something common throughout to get the pattern. So now, instead of the 1, then 2, then 3, could it be a case where you say 6 minus 1 will give you 5? You want to use these numbers to form the pattern. It's a formula. Use the 6 and see how you could get it. 6 minus 1 is 5. You see that? Use the 5 and see how you could get the 4. 5 minus 1 is 4. This 4 minus 1 is 3. Okay. So, it seems like this might be what is happening. If you look at this, let's put the equal 15 further out. You say equals 15. You say the 5 now, you call it 6 minus 1. Alright? The 4 here, let's move the equal 13. So this should be equal 13. The 4, let's use 5 minus 1. As for the equal 11, let's move that. Let's put equal 11 out here. What happened to the 3? Let's use the 3 as 4 minus 1. As for the 9, let's put the equal 9 all the way out here. And then the 2 becomes 3 minus 1. Then the 7, let's put it out here. You have the equal 7, right? So this is equal 7. This one now, it is now 2 minus 1. And what happened up here now with the 5? Let's move the 5 out here. The equal 5. Now, this would be 4 plus 1 minus 1. Okay, so it seems as if this is the pattern. 4 and 1, 5, plus 0 is 5. 4 and 2, 6, plus 1 is 7. 3 and 4, 7, plus 2. This would be 2. 3 minus 1 is 2. 7 plus 2 is 9. 4 and 4 is 8. 8 plus 3 is 11. 5 and 4, 9. 9 plus 9 and 4, 13. 6 and 4, 10. 10 plus 5, 15. Nice. We got a pattern here. So it seems as if we can fill this part out from now. It would be when you have n instead of 1, 2, 3, 4, 5, and 6, and so on. When you have n, what you really get is n plus 4 plus n plus 4 plus n minus 1. You see that? Now, this now could be changed up, because you could say n plus 4 plus, without the bracket now, n minus 1. N plus n is 2n, so it's 2n plus 4 minus 1 is 3. So call it 2n plus 3. So let's see if that would work. 2 by 1 is 2 and 3 is 5. 2 by 2 is 4. 4 and 3 is 7. Oh. 2, 3 is 6. 6 and 3, 9. 2, 4 is 8. 8 plus 3, 11. 2, 5, 10. 10 plus 3, 13. 2, 6, 12. 12 plus 3, 15. So it's 2n plus 3. Nice. So this is 2n plus 3. Alright, good. So this now would be 2 times 11. 2 times 11 plus 3, which would be what? 2, 11, 22. 22 plus 3 equals 25. So that would work out to 25. Right? Let me erase these things too. So this would be 25. You see that? Now, over here. Oh no, why this thing jumped all the way back up here. Alright, over here now. This is 1 plus 2 squared, 2 plus 2 squared, 3 plus 2 squared. So this would be n plus 2 squared. You see that? So this now would work out to be 11 plus 2 squared, which is what? 11, 12, 13. 13 squared. I think it's 169, no? 13 by 13. 3 3 is 9, 3 1 3, 1 3 3, 1 1 1, 169, right? So this would work out to 169. So it will be 169 here. Alright? Alright, we have this here. What is it that will give you this 49? Let's find out what happened at this point. You have 2n plus 3 gives you 49. I'm going to find what n is and put it here. So if you subtract 3 from both sides, so you have 2n is equal to 49 minus 3. 49 minus 3 is what? 46. It's 46. And then if 2n is equal to 46, divide both sides by 2, it's 46 over 2, 2 into 2, 1. 2 into 4 is 2, 2 into 6, 3 is 23. So this would be figure 23. Do you see that? Make sure. If you're not understanding some of the things, just make a comment and I'll address the comment that you make. Alright. Here now, we need this part here, the perimeter of the figure. We're going to get the perimeter of the figure now. So, 1 goes to 12, 2 to 16, 3 to 20. Now, here, in terms of the perimeter, getting the perimeter of this figure, let's see how we can deal with it. Let's deal with it over here in getting the perimeter of the figure. Oh no, what happened here? My gosh. Something strange happened here. What is going on? What happened? I'm not sure what happened a while ago. Document is not document I want. Seems as if I accidentally touched this document business. But where's the work that we were looking at a while ago? Seem to have disappeared. Hold on. Oh boy. It says, oh my. Why is it that it just jumped out like that? I just don't understand this. Word documents. Oh man. Word. Alright. What I'll do, you see? Can't seem to get back the work that was done. So I'll just end this video here and continue it using the figures that I had earlier.